Hello, my name is Daniel, and today I will be going through the AMC 10 of the year 2000 with you together from number 1 to 25, so let's dive right in. Problem number 1. In the year 2001, the US will host the IMO. Let the I, M, and O be distinct positive integers so that the product I times M times O equals 2001. What is the largest possible value of the sum I plus M plus O? So for us to have I, M, and O, we have to first divide 2001 into a few things. So 2001, we can see that 2 plus 1 equals 3, so we can see that 2001 is divisible by 3. So if we divide by 3, then we get 6, 2001, 3, 18, 26, 18, 21, 667. So we would get 3 plus 667 plus 1, since 2001 equals 3 times 667 times 1. This should look a bit more like a 3. So for us, when we get 3 plus 667 plus 1, this is 671. Therefore, it's number 8. Problem number 2, 2000 to the 2000 to the 2000th power, which should be like a 2-second for everyone. 2000 to the first power times 2000 to the 2000th power equals 2000 to the 2001st power, which is A. Problem number 3, Jenny ate 20% of the jelly beans, so if she ate 20%, she would have 80% left, right? So she'd have 80% left. This is 4 over 5. So second day, so we have 4 over 5 squared, right? So we can have, if there are x originally, then x times 4 over 5 squared equals 32. So x times 16 over 25 is 32, and x is 50. Therefore, 50 jelly beans is B. Problem number 4. Chandra pays an online service provider a fixed monthly fee plus an hourly charge for connect time. Her December bill was $12.48, but her January bill was $17.54. She used twice as much connect time as in December, so the connect time this would be 1754 minus 1248, which is 506, so it's 506. Her connect time bill was $5.06, and so fixed monthly fee, this would be 1248 minus 506, so which is 742. So it's 742. It's D. Problem number 5. M and N are the midpoints of P, A, and PB. So they're the midpoints. So this and this is the same. This and these are the same. And so, how many of the 4 quantities? How many of these are changing? So first, the length of the segment MN. If you see, this is MN, but MN is always half of segment AB. So AB stays the same, so MN also stays the same. A is not changing. Second one, the perimeter of PAB. PAB consists of AB and PB and PA, right? But then PB and PA, they are constantly changing as P moves, so B is changing. And C, the area of PAB. The area of PAB, for us to get the area, then we need this height times multiplied by this length AB, but AB doesn't change, and let's just say the height doesn't change, which means that the area doesn't change. So the area doesn't change. C is wrong. And D, the area of trapezoid A, B, and M, it's this trapezoid, and for us to know the area, we need to know MN, AB, and this height. But then, since AB is staying the same, and we just said that MN is staying the same, and this height is also staying the same, so these all stay the same, so the area doesn't change. Therefore, D is also wrong. We have only B. That's only one. That's B. Problem number 6. The Fibonacci sequence 1, 1, 2, 3, 5, 8, 13, 21 starts with 2 ones, and each term afterwards is the sum of its 2 predecessors. Okay, so which one is the last to appear? So for this one, I think we just have to keep doing it. So let's just write it out. 1, 1, 2, 3, 5, 8, 13, 21, and then we have to add these two, right? So it's 34, 55, 89, and then 144, and then we got 233, 377, and then 610. Yeah, right. Yeah, 610, and then yeah, I think that's all we have to do, because if you see here, we've got 4, we've got 9, and then we've got a 6. No, we haven't got a 6 yet. We need a 7, so we've got a 7, and we've also got a 0, so the 6 is left. The answer is 6. Problem number 7. AD is 1, P is AB, and they trisect ADC, so it's 30, 30, 30, and this is 90, so this must be 60, which means that this must also be 30. And if you put a line down here, and then this is not 90 degrees, then you can see that this triangle ADP, and then this triangle and this triangle must all be congruent. So that means that this is 1, so this must also be 1, so these are congruent, so this must also be 1, and since it's a 30, 60, and 90 triangle, we can see that if this is 1, this has to be 1 over root 3, and this would be 2 over root 3, and PB would also be 2 over root 3, right, since it's the same thing. So what we want is this added together, 2 over root 3 plus 2 over root 3 plus 1 equals 4 over root 3 plus 2 equals 2 plus 4 root 3 over 3, which is the same thing as B. And number 8, at Olympic High School, 2/5 of the freshmen and 4/5 of the sophomores took the AMC 10. If there were X freshmen and Y sophomores, then the number of freshmen and sophomore contestants were the same. So 2x over 5 equals 4y over 5. Divide the 5s, divide the 2, and this 2. X equals 2y. So we can put x and 2y here. So there are 2y freshmen and y sophomores. So there are double. So the freshman is sophomores times 2. There are twice as many freshmen as sophomores. The answer is D. Number 9, if the absolute value of x minus 2 equals p, where x is less than 2, then x minus p equals. Okay, so if x is less than 2, then x minus 2 must be less than 1, must be less than 0. So the absolute value of x minus 2 must be minus x minus 2. So this is 2 minus x. And x minus p, yeah, 2 minus x is p, right? So x equals 2 minus p. So what we want is x minus p. So x minus p equals 2 minus p minus p. So this is 2 minus 2p. So yeah, minus x plus 2. Yeah, so it's 2 minus 2p, so it's C. Number 10, the sides of a triangle with positive area have length 4, 6, and x. The second triangle with positive area have 4, 6, and y. The smallest positive number that's not a possible value of x minus y. Okay, so if we say that x is the greatest, no, let's just say that x has to be bigger than y. But it doesn't matter if x is smaller than y, because this has an absolute value anyway. So if we just say that x is greater than y, then we can make it so that x should be the greatest and y should be the least. Erase this one here, move this, let's just put them here. So if x is the greatest, then the triangle will be something like 4, 6, and x, so x should be less than 10. And if y is the least, the triangle will be something like 4, y 6, so y would be greater than 2. So x could be, so the maximum of x could be like, x could be, I don't know, 9.9, and y could be 2.1, and then their difference is 9.9 minus 2.1, so it's 7.8. So their difference cannot go beyond 8, so difference also always has to be less than 8. So the smallest possible number that is not a possible value of the absolute value of x minus y, that's 8, so that's number D. And problem number 11, two different prime numbers between 4 and 18 are chosen when their sum is subtracted from the deposit, which of the following numbers could be obtained. So for this one, we can say that two different prime numbers. So if the prime numbers are a and b, then their sum is subtracted from their product. A plus b is subtracted from AB. So AB minus A plus B, which is AB minus A minus B, which is A minus 1, B minus 1, minus 1. So this should be a number. So this should be one of the answer choices right here. So if we wanted to get A minus 1, B minus 1, then this would have to be this plus 1. So if we just add on 1 to, if we just move this here, and then add on 1 to these here, then it will be 23, 61, 120, 181, and 232. And so since A and B are prime numbers, then these have to be prime minus 1 and prime minus 1. And so, oh, this is 120 here, not 126. So if we go to 120, then we would get 10 times 12. This doesn't work because 10 becomes 9, and 9 is not a prime number. So let's try 6 and 20. This works. 5 times 19. 5 is a prime number, 19 is a prime number. Therefore, 120, this should be the answer, and the answer is C. Problem number 12, 0, 1, 2, 3, 1, 5, 13, and 25 non-overlapping unit squares. So would there be in figure 100? So if we look at this one, then the numbers are 1, 5, 13, and 25, but these don't give you much of a clue, right? So let's look at the figures. If you take a look at the figures, then, and if you like just exclude the center one, then you can see the pattern. Since if you draw a line like this, then you can see that we are able to kind of separate the figure into 5 parts, including the center. So this is 1 plus 0, right? But then this is 1 plus 1 times 4, and then this is 1 plus, there's 3 of these, right? So it's 3 times 4, but then this 3, this 3 comes from adding this one and these 2, right? So 1 plus 2 times 4, and then this would be 1, 2, 3 added together, so 1 plus 2 plus 3 times 4, and so it would all go on until, if it's figure n, then it will be 1 plus 4 times 1 plus 2 plus all the way to n. So what we want is figure 100, right? So for us to get figure 100, then let's just put 100 into n. So 1 plus 4 times 1 plus 2 plus all the way to 100 equals 1 plus 4 times 100 times 101 over 2. So this is 1 plus 2 times 100 times 101 equals 1 plus 20,200, which is 20201. So this is number C, and this is number C. 13. There are 5 yellow pegs, 4 red pegs, 3 green pegs, 2 blue pegs, and 1 orange peg to be placed on a triangular pegboard. So for this problem, if you focus on the lesser pegs first, then it seems like there could be so many ways, right? But then if you look at the bigger amount of pegs first, we can see that the only way that this would be possible is that if the yellow pegs are like this in a straight line. That is the only way that these pegs can be placed so that no horizontal or vertical column contains two pegs of the same color. And then it's the same thing, but with a smaller area. So same thing for the 4 red pegs. The only possible answer is here, and the green pegs, same. The only possible answer is these 3, the blue pegs, there's only these two possible, and the orange peg, this one is also the only one possible. So there is only one way to make it like this. So the answer should be 1. It's B. Problem number 14. Mrs. Walter gave an exam in a math class of 5 students, entered the scores in random order, and the average was always an integer. The scores were 71, 76, 80, 82, and 91. So for 71, 76, 80, 82, and 91, these scores are way too large, so let's subtract 70 from each of these. So if we subtract 70, then the scores become 1, 6, 10, 12, and 21. And then we can see easily that the first, if there are 5 scores, then the first 2 scores have to be summed to an even number. But if it's odd, then the only way is 1 and 21, and it's 22, but there is no other way that the third number can be put in so that the that the sum of the 3 numbers could be divisible by 3. So we have to say that these two should be divisible by 3, since the whole thing has to be divisible by 3, and they should be even, so that's 6 and 12. And then the third one should be 21, since that's the only way to make this times 3, make that a multiple of 3. And if we put this here, this is 18. 18 plus 21 is 39, and then plus 1, that will make it 40, and then plus 10, that will make it 50, which would perfectly like match the conditions that the problem provided. What's the last one Mrs. Walter entered? It's number 10. But then what we've done is we minus 70, right? So for us to get the real value, then we have to add 70 again. 10 plus 70, this is 80. It's number C. 15, to non-zero real numbers a and b satisfy a, b equals a minus b. And then we need to get this. So ab is under here, a squared plus b squared minus ab. But then a squared plus b squared, this is a minus b squared plus ab, right? Plus 2ab, right, in fact. So this over ab minus ab. This is a minus b equals ab, right? So ab squared minus ab squared plus 2ab over ab minus ab equals, if we get one ab out here, it's ab plus 2 minus ab. So these two cancel, it's 2, so it's E. 16, 28 lattice points. So for this one, it's really nice if you just put it on a coordinate plane. So point A is on 0, 3, and line AB, line AB, it's this line, and it's y equals minus 1 over 2 x plus 3, and for CD this is y equals x minus 2. So if we put these two together, then x minus 2 equals minus half x plus 3, right? So 3 over 2x equals 5, and x equals 10 over 3. So if the x equals 10 over 3, and we put that in here, then y equals 10 over 3 minus 2, so it's 4 over 3. So it's 0, 3 to 10 over 3, 4 over 3. So the area, so the line is square of 10 over 3 squared plus 5 over 3 squared. And then if we then if we just put this into a triangle, then we can see that this is 10 over 3, this is 5 over 3, therefore this is 5 over 3 times root 5, so it's B. Number 16, B. Number 17, Boris has an incredible coin changing machine. When he puts in a quarter, it returns 5 nickels. When he puts in a nickel, it returns 5 pennies, and when he puts in a penny, it returns 5 quarters. Boris starts with just 1 penny. Which of the following amounts could Boris have after using the machine repeatedly? Okay, so the important thing to note here is that putting in a quarter and putting in a nickel, they are all normal, so they don't change the money. But the thing is, if we put in 1 cent, then it returns $1.25. So it's 0.01 to 1.25. So we add on $1.24. So for it to add 24, so for it to add 124 every time, then it should be the amounts should be 0.01 plus 1.24 times an integer amount of times. So if we just want this now, we should subtract by 0.01 from the answer choices. So if we do that, it's 3.62, 5.12, 6.29, 7.44, and 9.06. So one of these will have to be 1.24n. So if we divide these by 1.24, then first 6.29 is not possible because it's an odd number, so it's not possible. And let's try 5.12. 5.12, so 500, so it's 512 divided by 124. No, 512 is 2 to the 9th power, right? But then 1.24 doesn't have only 2's, so it doesn't work. So B is out too. Let's try D, 744. So 744 divided by 124. This is 6, 5, 6, 4, 6, 24, 1, 4, 6, 7, 744. So N is 6 now, and it matches up, so it's D. 18. Charlene walks completely around the boundary of a square whose sides are each 5 kilometers long from any point on her path. She can see exactly 1 kilometer horizontally in all directions. So if we make a square, then the question is saying that she can see all points that are in a 1 kilometer radius. And then she can see the inside too, right? So it should also be like kind of like this. And then these would be semicircles. No, actually quarter circles. And then these would be together, 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 and together. So the area that she can actually see would be this area plus this area, and this area, just like that. So if we and we also know that it's 1 kilometer horizontally, right? So it's 1, and it's 5 kilometers long, so this is 5, and this is also 1, so we can know that this is 3, 3, 3, 3, and this is 5. This whole thing is 5. And so if we first try to get all these quarter circles tied together, then it makes a full circle, right? So its radius is 1, so it's pi. And for this area, these areas right here, we can have, so there are 4 of these, right? 4 times the length and the width is 1 and 5. 1 times 5, which is 20. So we have pi and we have 20. And for this region here, we have 5 times 5 minus this much, right? So it's 5 squared minus 3 squared, which is 25 minus 9, which is 16. So we have pi, 20, and 16. Pi plus 20 plus 16 equals pi plus 36, but pi is 3.14, right? Which is 36.3.14, 39.14, so this is closest to 39, so it's C. Problem 19. 3 point on the hypotenuse. Lines are drawn parallel to the legs of the triangle so that the triangle is divided into a square and 2 small right triangles. So what it's saying here is if we have a triangle, no, a triangle, a right triangle, yes. Then we have lines drawn parallel so that just like that, so that, oh man, this software is way too sensitive. And then here we can say that if the length of this is a, then this must also be a, and the area of one of the two small rectangles, let's say it's this one, it's m times the area of the square. So area of the square is a squared, right? But then the if we call this b, then triangle is 1/2 ab, but then this is m times the area of the square, right? So it's ma square. So if we cross off 1a and 1a here, then we can see that b equals 2ma. So if we just substitute b into 2ma, then the ratio should be 2m to 1, right? 2m to 1. This is also a to something. If we say this is x, a to x, so a equals 2mx, x equals a over 2m. So we can say that x is a over 2m. And then the ratio of the other small right triangle to the area of the square. So the other small right triangle would be this one, right? So the area of the square is a square. I should have erased that. And the right triangle is now a over 2m times a times 1/2, right? So it's a squared over 4m. So the ratio of the other small right triangle to the area of the square, this is a squared over 4m over a squared. This is, if you cancel these two out, 1 over 4m, so it's d. Problem number 20, let a and c be non-negative integers such that a plus m plus c equals 10. What is the maximum value of this thing? So this reminds me of a plus 1, m plus 1, c plus 1, because this is AMC plus AM plus MC plus AC plus a plus m plus c plus 1, right? But then a plus m plus c is 10, so we can swap this out for a 10, and then we have the plus 1 added here, and then we want this, right? So all we need is the maximum value of this. So if we want the maximum value of a plus 1, m plus 1, and c plus 1, then we want the maximum value of a, m, and c, right? So from here, a equals 4, m equals 3, c equals 3. That should be the maximum value. And if we put them here, if we plus 1 plus 1 plus 1 and multiply, then we get 5, 4, and 4. 5 times 4 times 4. This is 20 times 4. This is 80. So 80 is AMC plus MC plus AC. AMC plus MC plus AC plus 11. So AMC, no, not just AC. Plus, I forgot the AM. So this plus 11, right? So AMC plus MC plus AC plus AM. This is 80 minus 11, which is 69. So the answer is 69, and it's C. Problem number 21. If all alligators are ferocious creatures and some creepy crawlers are alligators, which statements must be true? If all alligators are ferocious creatures, so alligators are ferocious creatures and some creepy crawlers are alligators. Some creepy crawlers are alligators. There could be more, there might not be. We don't know this for sure, so let me just put a dotted line around it. And then, number 1, all alligators are creepy crawlers. Not all, because some might be not. So 1 is wrong. 2, some ferocious creatures are creepy crawlers. So some ferocious creatures are creepy crawlers since all alligators are ferocious creatures, then these must also be ferocious creatures. So ferocious creatures are in creepy crawlers. So this must be correct. So 2 is right. Number 3, some alligators are not creepy crawlers. We don't know that for sure because this might or might not exist. So it could be the case that all alligators are creepy crawlers, and this would be wrong. So number 3 would be wrong because we don't know. So it's 2 only, it's B. Problem number 22. One morning, each member of Angela's family drank an 8-ounce mixture of coffee with milk. The amounts of coffee and milk vary from cup to cup but were never zero. Angela drank a quarter of the total amount of milk and 1/6 of the total amount of coffee. How many people are in the family? Okay, so if there's an 8-ounce mixture of coffee with milk, then if there are n members of the family, then the total amount would be 8n, right? And then the amounts of coffee were never zero, and so this will be the total amount of coffee if coffee is as C and milk is as M, C plus M. And then Angela drank a quarter of the total amount of milk and 1/6 of the total amount of coffee. So Angela drank 8 ounces, right? 8 ounces is a quarter of the total amount of milk, so it's 1/4 milk plus 1/6 coffee. So if we multiply this by 12, then 96 equals 3m plus 2c. And so if we put c plus m equals 8n, then m plus 16n, right? So 96, 16n. 96 equals n plus 16n. So for us to get this, then 96 is divisible by 16, right? So m equals 16n minus 96, which is 16 times n minus 6. So for this to happen, no, actually m is minus 16 and plus 96, so it's minus n plus 6. 16 times 6 minus n. Yeah, I briefly got the plus and minus mixed up. And so if n is 16 times 6 minus n, let's move this up here. Then if this is correct, then from now we have to assume if m is 16, or if m is, I don't know, a different amount, like m, so m must be a multiple of 16. M is 32. So if we try out this one, then m is 16, then n should be 5, and if m is 16, then we put it in here. There are 4 ounces in Angela's cup. If m is 32, then n is 4, and then there are 8 ounces of it in her cup. But she drank 8 ounces in total, so she must have drank no coffee, but they should never be 0. So m equals 32. This is totally wrong. This is implausible. So m is 16 and n is 5. There are 5 people in the family, so it's C. Problem 23. What's the mean, median, and mode of this list? When they are arranged in increasing order, they form a non-constant arithmetic progression, the sum of all possible real number values of x. So from here we can just see right away that the mode is 2, and the mean is also fixed. It's 6 plus 9 plus 10 plus x divided by 2, 3, 4, 7. So it's 7 and 7 in the denominator, and x plus 23 in the numerator. No, x plus 25 in the numerator. X plus 25, so the mean is x plus 25 over 7. So this would become, so first if we assume that x, no, let's just put this in increasing order. 2, 2, 2, and then 4, 5, 10, and then we don't know where x goes. If x goes in here, then the median will be x, right? So let's try that out. If it's 2x, x plus 25 over 7, then x minus 2 would equal x plus 25 over 7 minus x. So 7x minus 14 equals x plus 25 minus 7x. So 7x minus 14, so 13x. This is 25 plus 14, it's 39. X is 3, and x is 3 totally matches with x being in between 2 and 4. So x equals 3. That is one possibility. And for the other possibility, if x is not here, but if x is like somewhere here, that means that if x is greater than 4, x is greater than 4, so the median will be 4. So it's 2, 4, x plus 25 over x over 7, right? And then, so x plus 25 over 7 will be equal to 6. X will be 42 minus 25, which equals 17. So x would be 17, and these are the only two values. And so if we add them all up, then it's 20, so it's E. Problem number 24, let f be a function for which f x over 3 equals x squared plus x plus 1. f3z equals 7, so here 3z would have to equal x over 3. X would be 9z. So since x is 9z, if we put 9z into here, it's 81z squared it's 81z squared plus 9z plus 1. So all values of z for this should be 7. So if we divide by 3, then 27z squared plus 3z minus 2 equals 0. So it's 9, 3, and 2, 1, and here. So the z would be minus 1 over 3 and 2 over 9. So the sum of all values would be minus 1 over 9. So it will be B. But there is a different solution, one that's much easier, so you wouldn't have to do any of this part. So from right here we can arrive at the answer directly, since the sum of all z values is equal to this under this, so it's 3 over 27, and then we need a minus in front of that, which is minus 1 over 9. This is actually a formula, so we're using that formula. So it's minus 1 over 9, which easily is B. So it's B is the answer. And our last problem for today, problem 25. In year n, the 300th day of the year is Tuesday. In year n plus 1, the 200th day is also a Tuesday. On what day of the week did the 100th day of year n minus 1 occur? Okay, so for this one, there are two possible ways to answer it. One is much shorter than the other, so let's just do the normal one first, the longer version. So most people will solve this problem using this, like, and actually like trying to do something with this one. But then, yeah, so let's just get on with the normal version first. The 300th day of the year is a Tuesday, and year n plus 1, the 200th day is also a Tuesday. On what day of the week did the 100th day of year n minus 1 occur? So for this one, you first need to know that there are 365 days in a year, right? And if you divide by 7, 365 divided by 7, this is 52 with the remainder of 1. This one is very important. So this means that 1 year later, the same date will have moved forward. One day. So here, in year and the 300th day of the year is a Tuesday. That must mean that if year n plus 1 is not a leap year, then the 300th day of year n plus 1 must be a Wednesday, since Wednesday is one day after Tuesday. So bearing that in mind, let's see. So the 300th, so it's year end right now. If the 300th day is Tuesday, then the 335th would also be Tuesday, since it's multiplied by since it's added by a multiple of 7, and 363, that would still be Tuesday, and 64, 65, this would be a Tuesday, Wednesday, and a Thursday. So the 0th day of year n plus 1, which is the same as the 365th day of year n, this would also be a Thursday, since these two are the exact same date. And so it's easier to add by multiples of 7 here. So if we try to make it as close to 200 as possible, then we get day 210. This would be a Thursday, and the 203, this would be a Thursday. So 202 and 1, 0. This would be Thursday, Wednesday, Tuesday, Monday. So if n plus 1 were a leap year, then the 200th day of year n plus 1 would be a Monday. But since it says it's a Tuesday, that must mean that year n plus 1 is a leap year. So if there's year n minus 1 and an n plus 1, we all know that leap years occur every 4 years, right? So if this is a leap year, then this is not a leap year, and n minus 1 is also not a leap year. So we now have to use this fact that n plus 1 is not a leap year, and neither is n. So if we erase it all and put it again, what day of the week did the 100th day of year n minus 1 occur? So let's come back to this one. The 300th day, year end at day 300, is a Tuesday. So if we subtract by multiples of 7, then we would subtract 280. So day 20 would be Tuesday, day 21 would be a Wednesday, and then day 0 would be a Wednesday, which is day 365 of year n minus 1. This would be a Wednesday. And the 100th day of year n minus 1. So we have to get to the 100th day, right? So if we just skip to day 15, that's still a Wednesday. And then add 70, that's 85, that's still a Wednesday. If we add 14 more days, that's 99. Day 99 is a Wednesday. That means day 100 must be one more, so it should be a Thursday. So it's A, and that was the 2000 AMC 10, and I hope you enjoyed this, and thank you for watching.